Hi everyone, welcome back to our YouTube channel City Education. In our today's video, we are going to derive time and space complexity for bubble sort. So let's get started. When we talk about bubble sort, I have already told you that bubble sort is based on the brute force methodology design approach. And what it does, it basically compares the adjacent element. So if I have been like 7, 3, to 10. So what it does, 7 and 3 it will compare. So 3 should come before 7. Then 7 and 2 it will compare. So this should come here. And then 7 and 10 it will compare. So in first iteration, it will bubble up the largest element to its correct position. So that is your first part. Then in second pass what it does, 3, 2, 7, 10. This is already sorted. So 3 and 2 will be compared. So if you see 3 and 2, 2 should come before 3 and then 3 and 7, then 3 is already at its right position. It means that now this 7 and 10 is also sorted. Now one more comparison, one more iteration, what you will have? You will have 2 and 3. That is you compare 2 and 3 because 7 and 10 are already sorted. 2 and 3, 2 is at right position, so this is also sorted. If you see, if you have n, that is 4 elements, iteration 1, iteration 2, and iteration 3, you need 3 iterations. We have already seen all of these in our previous videos. We have taken 3 examples. We have taken the key point discussions. So let's write that algorithm. We have also written the algorithm, but I'll quickly write. So I need one loop for the iterations and second loop for these comparisons. That is for I 0 to n minus 2. That is, if you have n elements, how many iteration you need? N minus 1. So I'm starting my iteration from count 0. So don't get confused, right? Then for j from 0 to, now these till where you need to go? N minus 2 minus I. I'm thinking it's right? N minus 2 minus I. Yes, n minus 2 minus I. Then what you do, you compare, you do this comparisons, you compare, you compare, you compare, you compare. That is, if a of j is greater than a of j plus 1. If the upper one is bigger or the thing which is present before it is bigger, you need to swap the position. That is, you swap a of j with a of j plus 1. As easiest as this algorithm. Okay, so this is the easiest algorithm you will see. Now to derive time complexity, what we do, we say that T of n is the function which denotes the number of times the basic operation is executed. Now, what is the basic operation here? Basic operation is nothing, the operation which is executed every time in the algorithm. So do you think uh, this swap is the basic operation? So no. Remember that swap is not a basic operation because this swap will only happen when this condition is true. But this comparison will always happen. So this comparison, you can write basic operation is comparison. You will always compare, right? So I need to figure it out how many times this comparison has happened. So if you remember in our previous video, if you have seen, I'll show you where we were discussing the number of comparisons as well. Okay, so if you see here, so you had made 15 comparisons. If you take one more example, you have made 10 comparisons. So if you see that it is in the form of n into n minus 1 by 2. Okay, so let's not go there. Let's drive it freshly. So t of n is nothing but this. That is number of times basic operation is executed. So you have two loops, loop 1, loop 2, and it is not a recursive algorithm. So what we are going to write that t of n is equals to sigma from I equal to 0 to n minus 2, and one more loop, that is 2 loop, that is j equals to 0 to n minus 2 minus I and 1. It is one time we are going to do this operation. Now if you solve this, can you quickly solve this? I equal to 0, upper minus lower, that is, you will get n minus 2 minus I minus 0, and then you do plus 1. So this is nothing but, if you solve this, I equal to 0, n minus 2, n minus 1 minus I. Now you put these value here. So what you will get? You will get n minus 1 plus n minus 2 plus n minus 3, so on so forth, 2 plus 1. So this is nothing but written as sum of n into n minus 1 by 2. Now this is what actual comparison. This is what actual comparison. But asymptotically what we do? What we do basically, we remove the constant and what is we are left with n square minus n, and we take the biggest function. So n square is the time complexity. So time complexity of bubble sort is O of n square. Now the question is it same? Is it same for worst case, average case, and the best case? So now this best case is subjective. Why is subjective? I'll explain you here now. So for worst and average, there is no difference, and there should be no difference in the best case also because you do the same number of comparisons. But in case you have a stable, if you talk about the stability, then this becomes O of n. This becomes O of n, right? So remember that it is same. O of n square is the time complexity for bubble sort because you need to iterate through all the iteration even if it is sorted. But in case you have to have a same number of elements, in that case, it becomes O of n. Let's talk about the time complex space complexity. So do you think you have used any extra space? I don't think I have used any extra array or any extra space in this algorithm where you see where you have used it. Nothing. I'm just swapping. That's it. Whatever the space I have of this array, this A array, same I'm using. There is no extra space. That is what space complexity of bubble sort is O of 1. So if you like our videos, please do like, share and subscribe. Thank you.